Ground-based telescopes have significantly enhanced our view of the stars by capturing more light than the human eye can perceive. Over the centuries, numerous instruments have been developed to study space, but none have matched the scientific advancements introduced by the James Webb Space Telescope, JWST. This telescope was specifically engineered to embark on a mission to uncover the origins of the universe, and it has delivered on that promise. In terms of exoplanets, the JWST has achieved a historic milestone by capturing an official image of what is referred to as the City of Lights on Proxima b, marking a transformative moment in our understanding of distant worlds. Furthermore, 18 separate images, one for each mirror segment, are expected to be collected. Yet this is just the beginning. Recently, the James Webb Telescope captured one of the clearest images of another exoplanet to date. Join us as we delve into this extraordinary discovery and explore what it could mean for humanity's future. If you'd like to stay informed on the latest developments in the universe and beyond, consider subscribing to our channel, liking the video, and turning on notifications. Thanks to the James Webb Telescope, scientists can now peer back in time to when the universe was just 200 million years old. The data gathered by this revolutionary invention will help us better understand cosmic evolution. Beyond that, the telescope can also capture images of the first galaxies ever formed, allowing us to witness the emergence of the first stars shimmering in the darkness of early space. The JWST's impressive capabilities are made possible by its massive 21-foot diameter mirror, which collects and reflects light to onboard instruments. Speaking of instruments, the telescope is equipped with 4 distinct tools, each designed to analyze different forms of light and offer unique perspectives on the cosmos. The first is the near-infrared camera, the primary imaging tool, tasked with capturing awe-inspiring images of distant galaxies, nebulae, and other celestial marvels. Next is the near-infrared spectrograph, which separates light into its component wavelengths to reveal more details about observed objects. The mid-infrared instrument focuses specifically on detecting infrared light and is optimized for studying exoplanets, the early universe, and even elements within our solar system. Finally, the telescope features the near-infrared fine guidance sensor and spectrograph, which ensures precise targeting and excels at detecting near-infrared light, ensuring no detail is overlooked. You may wonder why NASA chose to rely on infrared for the JWST when many other light spectrums are available. The answer lies in infrared's unique strengths. It can penetrate cosmic dust and gas that would otherwise obscure visible light. Moreover, infrared is perfect for studying cooler objects, such as forming stars, exoplanets, and faraway galaxies. By using infrared, the JWST can uncover features and phenomena that would be invisible through other wavelengths. One of JWST's most groundbreaking achievements is its first direct image of an exoplanet named HIP 65426b. Discovered in 2017, this gas giant orbits its star at a distance more than 100 times that between Earth and the Sun. To capture its image, scientists employed multiple filters on the JWST and combined the resulting data into a single, breathtaking picture. According to Sasha Hinckley, an astronomer at the University of Exeter in the UK and the leader of these observations, this moment represents a paradigm shift not just for the Webb telescope, but for the field of astronomy as a whole. What makes HIP 65426b particularly remarkable is its immense size, about 12 times the mass of Jupiter, and its vast distance from its host star, which made it easier to capture a direct image. But direct imaging isn't just about producing stunning visuals. It's about deciphering the origins of exoplanets and assessing their potential for supporting life. These images could yield crucial insights into how planets form and the nature of their atmospheres, paving the way for identifying habitable conditions beyond our solar system. Though current research suggests the likelihood of finding such a planet is slim, JWST's powerful zoom capabilities make it our best chance at locating a habitable exoplanet, should one exist. If that weren't enough, the telescope recently surpassed all expectations when scientists announced that it had observed the oldest galaxies known to humanity. These galaxies emerged when the universe was just 2% of its current age, a mere infant by cosmic standards. Astonishingly, the light from these galaxies traveled 13.4 billion years to reach us, making them the most distant galaxies ever observed. To put that into perspective, this light began its journey not long after the Big Bang and only now reached our instruments. Despite the enormity of this task, the JWST successfully detected and imaged these ancient formations, revealing how they looked over 13 billion years ago. Identifying such distant galaxies was no easy feat. Scientists first had to distinguish them from other celestial bodies, a challenge made possible only by the JWST's advanced infrared sensors, which picked up even the faintest signals. But detection was just the beginning. To confirm their age, researchers analyzed the data using the JWST's near-infrared spectrograph and measured each galaxy's redshift, a technique that determines how much a light wave has stretched due to the universe's expansion. The higher the redshift, the more distant and older the object. The galaxies in question had a redshift of 13.2, the highest ever recorded, confirming them as the oldest known to science. This discovery is monumental. These galaxies existed before the formation of the first stars in our own galaxy. The James Webb Telescope has granted us a window into the earliest epochs of the universe, and these insights could redefine our understanding of cosmology and challenge long-standing theories. In addition to these extraordinary breakthroughs, there has been growing scientific curiosity about JWST's ability to detect artificial lights, potential signs of civilization on distant planets. One compelling candidate is Proxima b, located 4.25 light-years away in the habitable zone of its host star, Proxima Centauri. It is believed that Proxima b is tidally locked, with one side perpetually in daylight and the other in eternal night. If a technological civilization exists there, they might have installed photovoltaic cells on the day side to generate electricity and light the night side. Remarkably, recent research suggests that the James Webb Space Telescope could detect city-like illumination on the dark side of Proxima b, provided the lights emit in a narrow frequency range about 1,000 times narrower than starlight. What's more, future NASA missions involving ultraviolet, optical, and infrared telescopes are expected to be even more sensitive, capable of detecting fainter levels of artificial light. The idea that we might observe the glow of alien cities just 4 light-years away is both thrilling and humbling. It reminds us of how much remains to be discovered across the cosmos. Thanks to cutting-edge instruments like the James Webb Space Telescope, we are closer than ever to unlocking the universe's most enduring mysteries. That concludes our exploration for today. We'd love to hear your thoughts. Do you think the James Webb Space Telescope is the ultimate tool for answering scientific questions, or do we need even more advanced instruments in the future? If you enjoyed this video, don't forget to give it a thumbs up and we'll see you in the next one. Would you like a visual summary or diagram illustrating JWST's major discoveries?